Okay, in this example, the coolest rocket company in the world is doing a little bit of a test of one of its propellant storage systems. And following the test, after it's filled up the tanks, it needs to drain them, right? Because you can't leave all that fuel in there after the test is done. We're going to put it back into storage. And the way this works is you take those full tanks, and you drain out the oxygen, you drain out the methane back into their ground storage tanks. And I want to know which one of these graphs represents the mass in the rocket, or the mass of the rocket, tanks, wings, everything, over time. All right, so let's talk about some of the important words in this big, giant paragraph right here, which you might want to pause and just read over again. But the important words to me seem like this. The oxygen flow rate is much higher than the methane flow rate. Okay, for whatever reason, the oxygen tank fills up faster and it drains faster. And, here we go, the initial mass of the rocket is 5,200 tons. Here's something else important that happens. At first, both tanks drain for 30 minutes. Then the oxygen shuts off, and here's another important thing. The slow methane tank continues draining for 30 more minutes, until finally, at the end, the rocket is down to 400 tons. Okay, it's mostly fuel. So, which one of these graphs shows kind of what's happening? Well, two of these I can rule out. Well, one of them I can rule out. See this thing? Hot garbage. Because you know there's something happening to the flow rate in the middle of this time period. Halfway through the hour, it changes. And instead of both tanks draining, only one of them is draining. And there's no kink in this graph, so you know that can't be it. But all of these other four graphs are actually reasonable graphs depending on what version of the question you have. Any one of them may be right. So for this particular version, I know I started with a filled rocket at 5,200 tons. That means this can't be it, and this can't be it, because those are rockets that are starting about empty at time zero. And I want something that's starting very full. And the other thing it tells me is that both tanks drain for 30 minutes initially, meaning I start off draining very, very fast and losing a lot of mass. And then later on, halfway through, it switches to slow flow methane only. So this is your fast section of the graph, and here's your slow methane only after the oxygen is done draining. This is the graph we're looking at.